Hey everyone, I'm just going to be giving a demonstration of my Formant synthesizer. So to begin, we're just going to see how it sounds, then I'm going to talk a little bit through my process for creating it. So I'm just going to turn it on. And as you can see, if you're not aware what a formant is or why this is useful, essentially my Formant synthesizer's goal is to mimic the human voice. And that is easier said than done. Obviously it's not perfect, but as I adjust the different formants, you can kind of hear the basis of what sounds like vowels in our speech. So the vowels are from the IPA, or International Phonetic Alphabet, and this is just sort of a big table that talks about all of the different vowels that we as humans can make, present throughout all different languages. So that is a brief demo of what it sounds like. We're going to talk a little bit now about the sort of signal flow. So at the very beginning, as you can see up here, we have the oscillators. So I'm using a square wave for that bass fundamental. And the reason why is that the square wave has a lot of harmonics, which are really important for the human voice because we have a lot of harmonics in our voice. And that's something that, for example, a sine wave could not really reproduce for us. This square wave is also controlled by vibrato. So I'm going to turn down the noise here so we can just hear the actual square wave. And I can control the speed of the vibrato by turning this up or down, as well as changing the depth. And what's really important about this and why I chose to implement this feature is that when we as humans say things or we sing, our pitch is not always constant. If it was, we'd get a sound sort of like this, which doesn't sound very human at all if you really listen to it. But when we add sort of vibrato speed and vibrato depth, we get sort of a much more natural sound that I think is much more indicative of a human voice. So the frequency can be adjusted via this sort of slider here. I generally just keep it at 440 for testing. And the other oscillator present that we're using is just sort of a noise oscillator. And the reason why is because a human voice actually has a lot of sort of higher harmonics present from actual movement of air throughout the nasal cavity, throughout the throat, and throughout the mouth. So turning that up a little bit sort of gives a much better sort of sound, in my opinion, just because we're getting sort of a bit of mimicking about the actual nasal qualities of our voice. So finally, we're going to talk about just the actual formant filtering process. So up here, you can see I have this formant data area. And what I did is I kind of scraped the internet for a table of the formant frequencies associated with every vowel. And essentially changing this formant index changes the actual center frequencies of these two resonator filters. The actual Q factor of these resonator filters is just sort of placed based on preference. I like to keep it pretty low. I think that sounds the best. But obviously your mileage may vary and you might want to change this up for your specific project. Finally, at the output, you can notice that changing these formant indices will actually not produce a very large change in the spectrograph. And that's because these formants are particularly focused on adjusting the actual frequencies between like 1 to 3,000 hertz, for example, even though our hearing range goes up to almost like 17,000 hertz. And so as a result, we get these large variations in the sound from changing this like little band right here. And even though we have these sort of ever-present harmonic frequencies all the way up the spectrograph. So some things that I think could be improved about this project. One, right now, this synthesizer is only limited to vowel sounds. And the reason being is that consonant sounds are much more difficult to reproduce and they would require a large rewrite of the program as well as a huge increase in complexity. So that's something to think about in the future, especially if I want this synthesizer to be able to like sort of say full words. That is really important. The other thing that I would like to implement at some point would just be attaching the frequency to sort of a MIDI keyboard and allowing somebody to, I guess, play this synthesizer like they would a piano. I think something like that would be really fun. It could create some really cool sounds and textures for music. It actually shouldn't be a very huge uh, step to sort of integrate. So that's essentially it for today. I'm going to include the actual project file in the description, and I appreciate everybody watching. Thank you.